curve, the par curve, and the forward curve. Starting with the concept of maturity structure, which means as the time to maturity increases on a given fixed income security, the yield is expected to be higher under normal circumstances. And that is our spot curve. So we will look at the different spot rates over this time. Different time periods will have different spot rates, which will give us the spot curve. We can also have something called the par curve based on the par rates and the forward curve based on the forward rates. And then in the final part of this learning module, we'll talk about the relationship between the spot, par, and forward curves. So, what have we talked about in the previous learning modules? We said that a fixed income security's present value, so we can price a fixed income security by taking its future payments and discounting these future payments back to today using a yield to maturity, right? A yield to maturity, and that yield to maturity was the same number across all the different time periods, all the different maturity dates. So we use the same number for the 1 year, for the same number for the 2 year cash flows, and the same number for the n number of. So let me just draw a dotted line over here to symbolize that it could be n number of years, right? That is your maturity. But we were using that one rate, single interest rate, called yield to maturity, which is basically the IRR of this fixed income security. Now, this is, you can think of it as a mixed rate. Why is it a mixed rate? Because all these different payments are coming in on different dates. And the return that this bond will give you, or this fixed income security will give you, is influenced by all those different payments. So if we want to know a different rate for each of these years, that what is the rate, let's say we talk about just one payment, let's say it's a zero coupon bond that we buy today and it pays us the face value exactly after 1 year. So what is the rate for that zero coupon bond? Or let's say we have a zero coupon bond that we buy at a relatively lesser price today, and it gives us that face value after 2 years. So what is the annual rate that we earn on that 2 year zero coupon bond? So the way of getting this is stripping these payments separately, right? And finding out what is that rate if we were to strip these cash flows into different years, and then just focus on that 1 year at a time and see, okay, what is that yield that we're earning for this 1 year cash flow, this 2 year cash flow, this 3 year cash flow? Because it's not a straight relationship that regardless of whatever is the number of years to maturity, the interest rate is the same. That's what a yield to maturity is basically implying, that you make the same return year over year. But that's not true. Usually what we have is an upward sloping yield curve, which means the longer the maturity, the later you get your money back, the higher the annual interest rate for that. And sometimes it even becomes negative or a downward sloping, and we'll talk about that later. But it's not always flat, which means we cannot have just one yield to maturity. We cannot have a single interest rate to calculate the price of the fixed income security. If we are really to calculate the proper value of it, which we call the intrinsic value, if we are really to calculate the intrinsic value of a fixed income security, so instead of present value, if I say intrinsic value, and then I can check whether that intrinsic value is higher or lower than the market price to know if it is currently overpriced or underpriced, and if there is an arbitrage opportunity. But to calculate the intrinsic value, I cannot use the same rate across all years. I need to use the rate for the first year, which will be different, and then the second year, which will be different than the third year. Now you might be thinking, why did I use Z for this? Well, there's three words which I want you to understand that will be used interchangeably, and these are spot, strip, and zero. Now, what does that mean? It means that if we are to strip these cash flows into different years, right, and or if we are to take the assumption of zero coupon bonds, like let's say we take these zero coupon bonds that don't pay us any coupons, and there's one zero coupon bond that pays us after 1 year the face value, or there's another zero coupon bond that pays us the face value after 2 years. So the rate that we earn on that first zero coupon bond could be Z1, because there is no other cash flow, so there is no mixing of these rates. It's just that pure 1 year rate. And with the 2 year zero coupon bond, we can calculate the pure 2 year rate. And the same thing can be done by stripping these cash flows separately and then checking the yield on each of those cash flows separately. So the zero rate or the strip rate or the spot rate are actually all the same things, which is each of those years have a separate rate, right? So that gives us that sequence of interest rates. And we also have two other ways of getting that sequence. The other one is called a par rate, and the third one is called a forward rate. I'll talk about the par rate and the forward rate later. For the time being, let's focus on the spot rate, or the also called zero rates, also called strip rates. Now, let's get into your spot rates and how the yield curve of the interest rates, that is, as maturity goes on, right? What are your spot rates? And usually it's like this. So Z1 will be lower than Z2, which will be lower than Z3. And we make this up to 30 years, right? So it goes from as small as 3 months to 30 years. This is called your yield curve. And of course, we're talking about government securities over here. So all these rates are for default free, risk-free securities. So as discussed, the term structure of interest rates is the relationship between interest rates and different times to maturity. The basic premise here is that interest rates change when inflation rates are expected to change over a period of time. Now let me explain that a little bit more. See, if you have your maturity here and if you have your interest rates here, usually what we have is an upward sloping yield curve. Let's say the current short-term rate is 4% and the long-term rate is 5%. Why there is usually a premium for that longer term investment? Well, it's because of the longer maturity, and something you learned in quantitative methods, that there is a maturity premium, right? And why do you pay a maturity premium? Well, it's because you're taking a higher interest rate risk. What does that mean? Well, it means that, let's say, if I'm locking my money for 30 years and you're locking your money only for 3 months, and if the government were to increase the interest rates further, so if the short term rates were to go up to, let's say, 6% because of higher inflation, because let's say there's too much inflation going on and the government decides to increase the rates. So what happens is that you will get your money back. Let's say you invested $100 in a 3-month treasury bill, while I invested $100 in a 30-year government bond. So you will get your money back within 3 months, and then you can invest it in the next treasury bill, which offers 6%, whereas I am stuck for 30 years at that 5% rate. So I'll be sad, right? Because my money is stuck at 5%, earning 5%, whereas you are earning 6%. So that's why when I go for the longer maturity, I take a higher interest rate risk, because if interest rates were to go up, I will be sad because I'm earning the lower rate. And therefore, there is a maturity premium for locking your money for longer. And that applies to banks as well, right? I mean, walk into your closest high street bank and ask them, okay, if I lock my money for 1 year, what will be the interest I will earn? If I lock my money for 2 years, what will be the interest I will earn? And definitely they will offer you a little bit extra for fixing your deposit or for an extra year. So that's the concept over here. But sometimes what happens is that what we see in the market is that this yield curve is sometimes downward sloping, right? It's downward sloping, that your 3 month rate might be 4%, but whereas your 30-year bonds might be currently having a yield of 3% instead of 5, right? Lower than your short term. And you might be thinking that makes absolutely no sense, because I thought there was a maturity premium and an interest rate risk. Well, yes, you are right. If the interest rates are expected to go up, then everybody who's locking their money for a longer period of time will want that risk to be covered, right? If interest rates were expected to go to 5%, then from now only I will want you to pay 5% on that longer term bond. But if interest rates are expected to come down, right, then it's a completely different story. And again, it depends on inflation, because if inflation expectation is that it's going to come down, then the market participants will say, okay, that means the Federal Reserve will reduce interest rates going forward. So the long end of the curve automatically adjusts to inflation expectations, which obviously is going to be reflecting in the short end once that happens. So let me repeat what I just said, because this is a complicated concept which at level 1 you need to sort of consciously try to listen to this again and again, and understand this. What happens is that the market is very smart, right? The market participants are very smart, and they have their long term expectation of inflation. And if they feel that inflation will come down, which means they expect the Federal Reserve to lower the rates, lower the interest rates in the future, so they will automatically price the long end lower today, right? Or if they think that interest rates are going to go up because they feel inflation is going to go up, so from now they will be asking for a premium on the longer term bonds, because they know the short term rate is going to go up in future, and they would like to lock the higher rates from today, so that they are not sad later on. And this is how the term structure works. Why, you might have heard sometimes in the markets, well, not sometimes, almost all the time, that if the yield curve is inverted, which means it's downward sloping, it's a sign of recession. Because if the market expects the inflation to go down and the interest rates to go down, it probably means that the economy has peaked and that now we are going into a recession, so that the demand will be cooling off, and that's why your inflation is expected to go down, because the economy is going to be going into a recession. Whereas if the inflation was expected to go up, that's when the economy is growing and it's heating and there's a lot of demand, right? So that's something you have to link with the discussion on business cycles in economics. Okay, so coming back to our spot rates. So let's say a 1 year zero coupon bond has a interest rate of 7.5%, whereas a 2 year zero coupon bond has an interest rate of 9.75%, right? Of course, assuming that everything else is the same, they are dollar government bonds, same credit rating, same currency, same periodicity, everything. So then what you have is that upward sloping yield curve, right? And using that, you can make the spot rate. We'll talk about par rates and forward rates shortly. Okay, so coming back to the spot rate, what did we say? That the Z1 is 7.5, Z2 is 9.75, and therefore what we have is this spot rate curve that can be made using these type of rates, and that's also called the zero or the strip curve because you're using zero coupon bonds. Or if you don't have zero coupon bonds, you're essentially what you're doing is stripping those cash flows separately to make a bond which only has that one cash flow coming at after 1 year, or that other cash flow which is coming after 2 years, and not taking any other cash flows into account, so that you can calculate that pure 1 year rate or that pure 2 year rate, right? And this is exhibit coming in from your curriculum that shows you that in normal circumstances what you have is this spot curve which is upward sloping, which means the longer term bonds have the higher yields, right? And this is usually observed in normal market conditions. But if your economy is going into a recession, and link this discussion to your business cycles discussion from your economics section, and what you will understand is that when the economy is going into a recession, demand goes down, inflation goes down, and and inflation is a lagging indicator. So even if inflation hasn't gone down already, it will be expected to go down. And if the market participants expect inflation to go down, they will already start paying higher prices for the longer term bonds, which will bring the maturity of the longer term bonds down, right? And then the yield curve will be inverted. So that's what happens. In unique circumstances, the spot curve can be even flat and even downwards sloping. Right. Now, there are some issues or some practical issues to consider with respect to your spot rate curve. And that's where we'll get the par and the forward rates to come in to help us. But let's focus on the issues with the spot curve first. Now, first of all, are all government bonds zero coupon bonds? The answer is no, they are not zero coupon bonds. Then how are you going to get these zero coupon government bonds to make this curve, right? I mean, if you don't have it, then how are you going to make it? Number one. Number two, usually people who buy government bonds buy them to hold them, right? So you do see them trading when they're just newly issued, but after a little time passes, and the newly issued ones obviously are called on the run securities. This is something we've discussed earlier. And the other ones are called off the run. So even if you didn't pick that point earlier, please pick it up now. So off the run securities are not traded that frequently. So which means they are less liquid. Not traded at all is incorrect. They are not traded that frequently. So I think a better word to use would be they are less liquid, right? Which means then you don't know what the market price is. And if you don't know what the market price is, well, how are you going to calculate the yield? So what we use is something called linear interpolation, and you know that concept from previous learning modules. And how that is done is, let's say you take the 2 year government price, so that's going to give you this yield, right, from the 2 year government bond newly issued. So you know the price, you know the yield. And then you take the 3 year, again, you know the price, you know the yield, right? This is going to be your 3 year. And then for the 5 year, you know the price, you know the yield, newly issued. And then you'll have your 7 year, which is going to be somewhere in the middle, maybe over here. I guess it's somewhere over here. This would be the 7 year. Then this would be your 10 year. And then you've got your 30 year. So the main thing is that this is all connected with these straight lines coming in through linear interpolation, right? And it's an assumption. So the 15 year, 20 year, 25 year yield could be definitely different than what we are implying through this linear interpolation. But this is a practical limitation that we have with government bonds, that they are just not there for each maturity, right? And that's where your forward rates and par rates will come in to help you. But for the time being, what I want you to do is appreciate the limitation that we have with government bonds, that the government doesn't issue bonds of all maturities. And number one. Number two, off the run securities are less liquid, so we don't know what the current price is. Therefore, we don't know what the current yield is. And that's why we use on the run securities for limited maturities to make the spot rate curve like this. Right? Now, once you take that spot rate curves, you could very well calculate the intrinsic value of a maturity, right? Also known as the no arbitrage value. So intrinsic value or the no arbitrage value basically means that that is the value of those future cash flows that you're calculating. In a way, you're discounting these future cash flows at rates which are the spot rates from your spot curve, which are so accurately taking into account the time value of money for each of those different years, customized rates for each different year that are calculated by stripping cash flows separately for each of those years or using zero coupon bonds for each of those years, and then you discount those cash flows back to today using customized rates for each year, and the value that you calculate is supposed to be so accurate that this is the no arbitrage value. If your bond is trading in the market at a price higher or lower than this, then there is an arbitrage opportunity. Right? Obviously, if it's trading in the market lower, then you will buy it and make money, risk-free money. You can borrow money from the bank and buy it, and you will get an extra profit more than the risk-free rate. Or you could short sell it if it is in the market for a higher price. And that is the whole concept, that if you take these very, very customized separate rates calculated for each year, which are your spot rates, right? Or the zero rates or the stripped rates, that will give you this intrinsic value. So here is a question for you. Please try to do it yourself. Pause the video, try to do it, and then I will show you the solution. Okay, so hopefully you were able to do that. Since it's a 5% annual coupon bond, so your payments are going to be 5, and then the future value coming in at 105 because the last payment is there, and then each of these Z1, Z2 and Z3 will be used to discount the cash flows, and what you should get is the present value as 102.96, right? And vice versa, you could plug in that 102.96 and calculate the YTM, right? If it was a single rate, and that comes to 3.93, which is kind of an average of this 2, 3, and 4. So now you get that the YTM is a mixed rate and the separate rates are separate. So if you have your Z1 and Z2 and Z3, and it's going on as from 2 to 3 to 4, right? So it's an upward sloping yield curve, and a coupon that pays a higher rate will obviously have a different present value because the rates are different for each of those years. So what we need to appreciate is that if you take a single YTM, it doesn't really capture the separate rate of each year, and some bonds could have higher coupons, so their initial year cash flows could be higher. That's why we need to use a specific rates for each of those separate years to calculate the intrinsic value of a given fixed income security, right? So this is just a timeline that is here for you, that how you're taking those separate cash flows and discounting them back at the specific rates. Right, so let's take a break here, and then we'll come back and get into how we can use par rates and forward rates, and why they are better sometimes to use to then imply the spot rates, right? Because of the availability of forward rates at all maturities. So we'll come back and talk about that.